Welcome back. You ready to execute that subclass? I know I am. But first, we have to make one quick correction from the previous video. The default value for our EWS address is incorrect. We have a different endpoint that we connect to. So instead of smart connector weather service, we will put ecostructure/data exchange. And save that. Now, when we implemented the required abstract processor, Visual Studio stubbed out the main entry point for all custom logic, which is execute subclass. It is here where our actual work code will go. Before we implement our custom logic, let's take a moment to review some general topics about this method. The return type is a list of prompt instances. This can be used to report any problems encountered when your code is executed. Presently, these are only used for logging purposes. If no messaging is to be conveyed, then an empty list should be returned. Loops in your processor code are expected here as well. Well-written processor code must still be responsive to external input from users, the operating system, or the Smart Connector runtime. To achieve this, the base class has a cancellation token property that is managed by the Smart Connector runtime. Processor code must monitor this if loop constructs of any type are present, even if they are short loops. This can be done in two different ways. The first one is the protected isCancellationRequested property that can be used to determine if a stop is pending. The method should then terminate as soon as possible after performing any required actions. I will show you what this looks like with a short live demonstration. Just delete this line here. We will create a list of prompt objects, which can be named anything. Sorry, the object is called prompt, not prompts. We put down a do while. Your custom code for doing your work will go in the do section, with the ending of while not is cancellation requested. And return the prompts. A somewhat less graceful, albeit faster alternative can be achieved by calling the protected check cancellation token method. This approach should only be used if an uncontrolled and immediate termination of the method is acceptable, as it will cause a task canceled exception to be thrown if a stop request is pending. Smart Connector will call the virtual cleanup before cancellation method prior to throwing the exception if cleanup of any type is required. This can also be briefly demonstrated here. So what we will do is just simply make a new region. Cleanup before cancellation override. Let's just get things nice and neat for a bit. And there you go. ReSharper will just put that down there for us. And where the baseline is, you can put whatever you want. Now, a processor is expected to complete its execution in a short, finite amount of time. This is required for a variety of reasons, but most importantly so other processors can also execute. Remember, there are only a finite number of configurable threads for processor execution, and if there are several processor configurations hogging the available threads, other work may not get executed as expected. If a processor has not completed in the time configured in the portal settings, the Smart Connector runtime will terminate the thread it is executing on. For a variety of reasons, it may not always be practical to design a conforming processor which runs in a short amount of time. Smart Connector runtime can accommodate this situation. Developers need to only implement the interface long-running process. This is a very simple thing to do. All you will have to do is move up to the top of the code. After you've taken a couple seconds to get caught up, we will go up here, comma, long-running process. Before we implement execute subclass override, let's review what we have so far. Just take the time to pause the video and look at your code. Now it is time to stub out execute subclass. After a small amount of cleanup, just to get neat and tidy. Remember, it's always best to put every major chunk into regions. This is for good organizational practices. Everything should be in nice working order. So this section right here is not necessary, but we can comment it out for now, as we just stub out the functionality. So what do we need? Make sure we can connect to an EWS server. If the server isn't running, start it now. Confirm that the server settings are how we want them to be. Add the fields. That a client can use to set the location. Add the folders and data points, where we'll write the current weather conditions in update processor, which we will get to in a later video. Add the folders and data points, where we'll write the forecast. Return any issues right at the end. Much like the God object is an anti-pattern, the God method is an anti-pattern as well, and you won't see any code like that in these examples. So we need to add some methods. Please do not worry about any errors so far, because a lot of the stuff we are adding right now does not exist yet. Like is connected, for example. We will get to that soon. this is where we're going to be accessing the data adapter class. If the data adapter .server is not running, we start it, and we will cover more about the data adapter very soon. An instance of the EWS server data adapter is what we will be using to bootstrap and configure the native Smart Connector EWS server. There is no public constructor for this class. Rather, you will need to use one of the two static methods to acquire an instance. We will illustrate how we will do what is called the lazy loading design pattern. When you get a second to make sure that you stubbed out your execute subclass, just as I have, then we can get on to the isConnected and data adapter pieces of the code.